this complex universe is fine-tuned for life? Is it the case that this is the only way this universe could have and must have existed? Well, Stephen Hawking doesn't think so, and we'll see why. Hey everyone, welcome back to another episode of SAF Podcast. You're joining us as we continue our journey through the fine-tuning teleological argument. We've been exploring the reason why we must ask for an answer as to why the universe is the way it is. We've seen in the past episode how the universe has all of these different quantities and constants, arbitrary quantities and constants, that if they were to face even the slightest change in their value, the universe would be absolutely hostile to life. And we're talking about each of these individual constants and arbitrary quantities, all of them having to have particular values that do not permit any minute change. Because if they were to do so, any one of these values or these constants, then the universe would not permit life in any extent. And in the last episode, we looked at different ways to ask ourselves, why should we ask for an explanation? Why can't we just take it as it is? And now we are going to move forward to ask the first question in this next set of series. So before that, Piyush, what is the fine-tuning argument that we've been discussing about?
Yeah, well, the formulation of the fine-tuning argument goes this way. Premise 1, the fine-tuning of the universe is due to either physical necessity, chance, or design. Premise 2, it is not due to physical necessity or chance. Therefore, it is due to design.
Yeah, I mean, like we have covered, I think you would recall this, Piyush, and some of our viewers who've been here on the Natural Theology series for a while will also recall. In one of our earlier episodes, we had talked about how there are different types of philosophical arguments to make the case. So we talked about what is called as a deductive argument. And a deductive argument has this exact format. So there are a couple of statements, we call them premises. And if they are true, and if the logic that connects each of those premises is valid, then the conclusion must inevitably follow. And so it's a very airtight way of presenting the argument. And the fine-tuning argument follows the same thing. As you've seen with the moral argument and the Kalam cosmological argument. So do check out those series as well if you're looking to learn these arguments on your own. So we're going to talk about the physical necessity part, right? So as to what that means. Well, quite simply, as the word itself says, it is physically necessary that this is the way the universe has to be. So the whole question that we're asking is, well, the universe is fine-tuned for life, but that's clear. And what we're asking is, why is it so? Is it because this happened by chance? Is it because there happens to be some sort of designer who designed it to be the way? Or is it the case that this is the only way that the universe could have existed? And that's why it is. Hence, no need for any further questions. That's the first option that we have to deal with. Now, from the onset, what we see is that it is possible enough to be entertained that this could be the reason. But it seems difficult for us to make sense as to why the universe, for example, could not have expanded at a rate different than the rate at which it expanded. And that is one of the fine-tuning elements at play, right? The expansion of the universe, as we discussed earlier, the interplay between gravity and the dark energy is what gave form to the formation of heavy elements and all at the onset of the universe, the subsequent formation of galaxies, planets, and all of that. So the expansion is just one thing that we are picking up right now. So to recap, just from the onset, the question remains, why is it the case? I mean, what is the reason that the universe could not have expanded at a different rate? And we can ask this for all of the other constants and values that are at play. But that is a place that we are going to take off with.
Yeah, so talking about physical necessity, the first thing which comes to my mind is the theory of everything. So do you think the theory of everything would make a case for physical necessity?
Yeah, this is, from my reading, what I could gather is that this is still a space for further knowledge and exploration and research to be done into. But at an overview, like what the theory of everything looks like is that its goal is specifically to give us a unified theory of the four fundamental forces of nature. Now, we have gravity, electromagnetic force, strong and weak nuclear force. The theory of everything's focus is to give us a theory that brings all of this together as a singular force, which is carried by a fundamental particle. Now, this theory of everything would hopefully tell us why is it that these forces have the values that they have. But then again, it doesn't tell us everything as the name tries to suggest. It's an area, like I mentioned, where a lot more of research and exciting discoveries are going to be made. But maybe to say that this is going to give us the theory of everything, maybe a bit too much to expect from it, but time will tell. But as of right now, it doesn't seem to be a contender as to why the universe must be this way or anything of that sort.
Okay. And another, a strong contender for the theory of everything comes in the form of the superstring theory, which is also at some places called as the M theory. When talking about M theory, I recall this is what Stephen Hawking had to say about it. So let me just quote it from, this is taken from his book Cosmology from the Top Down. Actually, it's a paper which was presented at the Davis Cosmic Inflation Meeting in the UC Davis on May 29, 2003. So from this paper, we are going to quote some of his writings in this episode. So just try to follow as I read it out. Okay, so he says, does string theory or M theory predict the distinctive features of our universe, like a specially flat, four-dimensional expanding universe with small fluctuations and the standard model of particle physics? Most physicists would rather believe string theory uniquely predicts the universe than the alternatives. These are the initial state of the universe is prescribed by an outside agency code-named God, or that there are many universes and our universe is picked out by an anthropic principle. So it seems like Hawking is confirming that there are only three options to make sense of the current state of the universe, isn't it?
Yeah, exactly. So what Hawkins is covering in that, like you said, Piyush, as you said, is that there are three options to make sense of the distinctive features of a universe. Now he says that most physicists would say that, as you read out, right, that the string theory predicts this exact universe. In other words, string theory says this is the only way that the universe can be, that is physical necessity. So he said that most physicists would lean towards that and they would prefer this over the other alternatives. What are the alternatives? The other two alternatives, the first one is that it's design. There's an outside agency codenamed God. That is the reason why we have these specific features of the universe. Or, he says, well, it could be attributed towards the anthropic principle. Now, that is a way to say that this has happened by chance. So, if you were to review this to bring these three options all together, it lines up with what we covered in the initial formulation of the fine-tuning argument. Now, with the anthropic principle, I'll just make a point before we move on. What we mean by the anthropic principle. The key point of the anthropic principle is very similar to the puddle analogy that we covered earlier, right? What was the puddle analogy? Yeah. Well, there's a big pothole on the road. The rain fills it, a puddle forms, the puddle wakes up, and it says, oh, look at it. This pothole is so fine-tuned to suit me. It must have been the case that this was created especially for me. But what the analogy tries to show, and it fails in doing so, as we covered earlier, it's trying to say that just like that puddle, we just evolved, adapted to fit into the spaces and pockets of this universe, to extend the analogy forward. And then we realize and say, wow, look at it, how well we are fitting into the space and pockets of the universe. So the universe must be specifically arranged for me. So the analogy tries to say that, well, that's not the case. You just happen to evolve by chance to be adapted towards the universe, which is why it looks like it fits like hand in glove. The anthropic principle takes that, but in a very academic way than the puddle analogy, obviously. The anthropic principle makes the point that the reason we are able to observe the universe and say that this is so specifically catered towards us is that It just so happened that a species that is capable to observe these fine tuning happened to evolve. That's a very rudimentary way of understanding the anthropic principle. Like I said, this is again a way of saying this happened by chance. Well, it just so happened that the species that is navigating and charting the dark corners of the universe happened to be the one that is able to make sense or understand or explore the fine tuning. So it is no wonder that we look around and find fine tuning, because we just happen to be the kind of species that would find these fine tuning features in the first place. So that's the anthropic principle part. But Stephen Hawking doesn't just end there. He goes on to say a bit more. So what does Stephen Hawking say next?
Yeah, well, he then goes on to say that M theory cannot predict the parameters of the standard model. Obviously, the values of the parameters we measure must be compatible with the development of life. But within the anthropically allowed range, the parameters can have any values. So much for string theory predicting the fine structure constant. Then he says, even when we understand the ultimate theory, it won't tell us much about how the universe began. It cannot predict the dimensions of space-time, the gauge group, or other parameters of the low-energy effective theory. It won't determine how this energy is divided between conventional matter and a cosmological constant or quintessence. So, to come back to the question, does string theory predict the state of the universe? The answer is that it does not. It allows a vast landscape of possible universes in which we occupy an anthropically permitted location.
Yeah.
Yeah.
I mean, that's a key clincher, right? In one way, he very unequivocally states that does string theory predict the state of the universe? The answer is that it does not. And then he says that there's a vast landscape that the theory gives way for. And the size of that landscape is 10 to the power 500. Well, that's 1 followed by 500 zeros, which is a humongous figure, right? It's very difficult for us to even imagine in our head what that would look like. Because out of that figure, you could remove a billion and you would still be looking at something that to our mind would look like infinity from a quick observation. That many possible universes could be there, governed by the present laws of nature, right? Which means that there are so many different ways in which the arbitrary values and the arbitrary quantities and the constants that are essential to understanding the fine tuning could have been like. So gravity could have been, the force of gravity could have been different. The ratios that we've covered before could have been different. The entropy at the initial point of the universe could have been different, and all of them could have been way different all across these universes. And here Stephen Hawking refers to this, the anthropic principle coming into play here, right? He says, well, this is vast landscape and there's a space within which we could have evolved and come to take place. So he's sort of leaning towards that, at least that's what it seems. Now, the fundamental point is that for the anthropic principle that we covered just before, for that to hold effect, for that to be a valid point, a valid reason to be considered here, the multitude of universes that are out there must be real than just the possibility of us saying, well, it could have been that way. So in other words, we would have to have something quite close to a multiverse in existence for the anthropic principle to take effect and give form to this universe with this set of observers out of the 10 to the power 500 possibilities that are out there. What this shows is that the leaning of existing brilliant thinkers and past thinkers like Stephen Hawking himself on where to make sense of the fine tuning. Like, one thing that's becoming more and more clear is that they are all confirming that there is fine tuning at play. There is astonishing arrangement of the building blocks of the universe that permits life. And everyone is trying to grapple for answer. And that is where we're all getting towards it. And that is the whole point of the fine tuning argument as well.
Yeah. I mean, when we look at the number like 10 to the power 500, so having a life permitting universe within this range of 10 to the power 500, isn't it quite big?
Yeah, I mean, yes, it does look like that, right? When you think about 10 to the power 500 possible universes, it would appear to say, well, at least one universe out of that has to have all of the pieces that fell into place that just is the way the universe is right now. Like, this universe should have filled in out of that vast number. Like I said, it looks like that at the get-go, but a couple of things that stand out is that one, when we take the ratio of all of the possible number of life-permitting universes against all of the possible number of life-prohibiting universes, we end up seeing that it is an improbability at play, right?
Yeah.
It is not an impossibility. It's not an impossibility. It's an improbability at play. And a way to, and the reason that stands out is that we're talking about a set of compounding improbability. So let's run with Stephen Hawking's point for a while. The reason that this improbability gets so big is because a lot of these arbitrary quantities and constants are independent of each other. So we are not just talking about if you get gravitation's force or the gravitational constant correct, you're going to get 10 other stuff correct, right? What we're looking at is you need to get this correct, and then you need to get this correct, and then you need to get the other one correct. You have to get all of these independent values all to go hand in hand, all to go at the exact spot that they should be for the end result, which is a universe where life can exist, to come about. And if you're familiar with probability theory, you will, as Piyush, you would have obviously learned about it, where you add the probabilities of one with the other at the other, and eventually you see that the final probability is extremely difficult to come to terms with, right? So the probability of us playing dice and getting a number 6 on the first roll is 1 out of 6. That's pretty straightforward. But for us to roll 2 dice consecutively, and for us to get the probability of 6 on both of those 2 rolls consecutively is 1 divided by 6 into 1 divided by 6. That's a chance of 1 out of 36, right? It just became incrementally different than 1 out of 6. It's not 1 out of 12. It's 1 out of 36. Why? Because you could get 1 and 1, you could get 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and... You could get 36 different possible outcomes. You could get a 2 and then a 6. You could get a 3 and a 3. It's just one outcome that's there, that is 6 and a 6 out of the all 36 different possible outcomes. Now imagine if you roll a dice for 3 times. The probability of getting 6 on all 3 gets even more minuscule. And this is the compounding probability fact at play here. And to bring up a specific universe example, is that, we talked about the cosmological constant having the specific value that it has, that it is fine-tuned to 1 part in 10 to the power 120.
Yeah.
Now that's one improbability there, highly improbable, but let's take it that. Then we talked about the odds of the gravitational constant having the value that it has, which is 1 part in 10 to the power 100. So what we are eventually looking at is that bringing both those probabilities together to get a universe where both these values have the values that they have. The probability of that is 1 part in 10 to the power 220. Right? And the reason is because you have both of these improbabilities combined together. It's compounded together to give you a larger improbability.
Right.
That's just 2. And we have reached 10 to the power 220. Right? We have a maximum of 10 to the power 500 to deal with. So the moment we add in a couple of other constants or quantities that must be met, we would have run out of enough universes that string theory permits us to get this by random chance or by some sheer luck. And that is the challenge that's at play. It's that we don't have enough possibilities to explore all of this to say that, well, we could get this by chance. Which is why Paul Davies, a renowned theoretical physicist, he comments that it seems then that the physical universe does not have to be the way it is. It could have been otherwise. He remarks this in his book, The Mind of God. And in this section, he's talking about the initial conditions that govern the universe, which we covered earlier, right? The initial level of disorder or order in the universe, entropy level in the universe. There was very little disorder at the beginning point of the universe. And it's a question. Why was that the way? It just was, right? That's all the scientific world can say for now. It just happened to be that the initial order of the universe was quite high. The amount of disorder was quite low. There was low entropy. And that turns out to be a critical component that enabled life to exist down the line. And what Davis is saying is that, in that sense, he goes on to comment about it. What he's saying is that nothing we know of the initial conditions tell us that this universe must have been a unique and only universe.
Yeah.
And that's the point that Paul Davis also makes, and as we covered with Stephen Hawking as well. So in essence, what that leads us to say is that we cannot hold on to physical necessity as a potential candidate. It's no longer a viable candidate. We can't say that this universe is the way it is because this is the only way it could have been. Absolutely not. It could have been n number of different ways, but yet it is this way. So we have two other options to explore. Is it chance? And if it's not chance, and if it's not physical necessity, then is it design? Which is what we will cover in the upcoming episodes.
Yeah, well, I think that was pretty clear, and thank you, Jacob. I myself had some questions and doubts about this, but I think you put it forward in a very good and easy to understandable way. So yeah, as Jacob mentioned, in the upcoming episodes, we'll be looking at the two other reasons which we are left with. One is chance and one is design. So stay tuned and stay connected with us so that you stay updated on the upcoming episodes. And before closing, I would like to reiterate what the fine-tuning argument states. Premise 1 says the fine-tuning of the universe is due to either physical necessity, change, or design. Premise 2, it states that it is not due to physical necessity or chance. Therefore, it is due to design. So with that, we come to the end of this episode, and we wish you a great week ahead, and we'll see you in the next one.
Thanks for tuning into SAF Podcast, where faith and reason unite to equip seekers like you. If any of today's conversation struck a chord, share the knowledge to help others on their journey. Join our community on Facebook, X, Instagram, and YouTube. And don't forget to rate and review us on Apple Podcasts and Podchaser. Your feedback fuels our journey. Dive deeper with our free ebook at ebook.saftapologetics.com. For more about our team and our passion, visit saftapologetics.com. SAFT equips believers to defend their faith anytime, anywhere.